All right, Algebra 2. Welcome back, guys. We are in Section 7 today. All right, Chapter 10, Section 7, all about solving nonlinear systems, which basically this whole chapter has seemingly been about nonlinear systems with circles, parabolas, ellipses, hyperbolas, all of those things. Nonlinear. Linear, remember, makes a straight line. But I want to say congrats. You guys made it through another chapter. Section 7 is the last section in Chapter 10. And I want to keep pumping you guys up, all right? I know we're getting a little bit closer to the end of the school year here. Just a few more chapters to go. You guys keep working hard, okay? Don't give up. Don't let yourself, give in to that temptation of just checking out. All right. I know that everybody has those moments, and that's fine. You're just being a human being. All right. But don't let yourself fall into that trap consistently, which means that it's going to become a habit. And then if it becomes a habit, then that starts to be something that just affects your character. All right. And I know that you may say, wow, that's too extreme, but unfortunately it's not. All right. I've seen it happen to too many students. So you guys got this. Keep working hard. All right, let's do it. Section 7, nonlinear systems. Again, everything that you see that's highlighted, you gotta copy it down. Okay, so everything in that first paragraph there, nonlinear system of equations, basically what you're dealing with, that's going to mean that you have at least one equation. They're going to give you two, but at least one of those equations is nonlinear. You may have an equation that makes a straight line, but the other equation is going to make something else that we've dealt with in terms of a conic section from this chapter. All right. When you combine those two equations into a graph, meaning both equations are graphed together, you're going to either have no solution, meaning that those two graphs do not cross at all. You're going to have one solution, meaning that they will cross or touch only one time. By the way, this is, we can kind of zoom in here, dealing with a no solution. One solution, meaning that they will only touch in one location. You could have two solutions, so touching two locations, three solutions, touching obviously in three locations, or four solutions, touching in four locations. Okay, so make sure that if you just find one location, that you are confirming that that graph really does only touch in one spot. Because if you graph it on the graphing calculator and you see there's a lot of overlapping parts, then you're going to have multiple answers. And you have to represent all of those answers when it comes time to give your solution. All right, so see the picture below? That is this. This is just examples of what it could look like with none, 1, 2, 3, or 4 solutions. All right, then what we're dealing with here is there are technically 3 total methods to solve this system of nonlinear equations. All right, one method is graphing. All right, and if you are going to use the graphing calculator, which I will admit sometimes is by far the easiest. All right, all the equations have to be set up, solved for y. So right here, need to solve for y if you're going to use the calculator. Okay, so don't forget that. If you don't have the equation saying y equals and then everything else, you cannot use the graphing calculator. That's not going to cut it. All right, so that's step 1 if you're using the graphing calculator. The other 2 styles, one of them is substitution, which is just algebraic. You're going to need to manipulate everything, then substitute it, solve it, bring it back in. I'm going to show you how to do one. The other one is the elimination method, which is another algebraic method. Okay, you guys did substitution and elimination all the way back in Algebra 1. No, the problems were not this hard, but technically you have done that before. And we've done a little bit of it also this year in Algebra 2, but it's just that the equations look a little bit different. All right, some may have squared, the other one may not, but you're going to see us do those. All right, and I wanted to give you a few examples right here already worked out. Okay, this is if you're using the graphing calculator. So step 1 is make these equations set up for y. So that is right here, solve for y. And they do that right there for the equations is they set them up so that they say y equals. Then you plug them into the graphing calculator. Okay, set that one for y1, set that one for y2, plug them in, and then look at the graph first just to kind of get a visual of how many times you see them touch, cross, or overlap. Then after that, you're going to then need to use the table feature in the graphing calculator so that you can actually get the exact precise number of where they are touching, crossing, or overlapping. All right. Now, if we're going to use substitution, there's actually a few steps to this. So you can see a lot more highlighting being done for substitution. All right. That means that we're going to have to solve for one of the variables, plug that variable, this is solving, then plug that variable in, otherwise known as substituting it in, solve all of that, simplify it down, then you have to substitute these answers back in to one of those original equations. So unfortunately, no, this is not a quick method. And the problem you're going to see us do in this video, it's a little bit longer. But elimination, if it's set up for that, here's how you're going to notice easily one of these coefficients should be the same. And if they are, then elimination is quick and easy. It's pretty direct also. All right, so you see that we have a 9 with the y squared, another 9 with the y squared. So we could use elimination for that. All right, so all of those things that are highlighted need to be copied down. There we go. Let's jump into our example problems here. I've basically worked the first one out because we are using the graphing calculator. So I'm going to guide you through how I did it, but you can see everything there is already done. So solve by graphing. The first original equation is right here. 3x plus y equals 4.5. The second right here, we worked out as y, actually it was given already for y. So y equals 1/2 in parentheses x minus 3 and that quantity squared. So that meant that this equation here needed to be set up. That's why I moved it over here, solving for y. So what I did is I took the 3x, I moved it over. That's why you're going to notice a negative 3x here. Okay, positive 4.5 because that didn't move. This equation is already set up for y. So what I did is I took this one because it was already set up for y. I made this y1 in my graphing calculator. And then I made this one y2 in my graphing calculator. Does it matter which one you make, y1 and y2? No, it does not. So you could flip those in terms of y1 and y2. It doesn't matter. What does matter is they both have to be set up for y equals. Okay? Plug those into the graphing calculator. Then follow this note right here. After both are set up for y equals, plug them in. Graph it. Then go to the table feature. How do you get there? Push second, then the graph button, and that'll get you to the table feature. Look for where y1 is equal to y2. That means this is where they cross paths. Now, they will actually only cross paths once. Look through that table, and you will see y1 and y2 both become 4.5, the same number. In other words, they are equal when x is 0. That means that is the point where they intersect. Therefore, this is your solution. One solution. All right, let's move on. Example problem 2. Here's the substitution one. So this one you're going to have to pay close attention. Let's go through all the steps. Step 1, solve for one of the variables. All right, and so what I did is I'm going to solve for x by first taking y and moving it over to this side, meaning that I will now have an equation where x equals negative y minus 1. And I'm going to put that into parentheses because that entire expression is what I will be plugging in to the x value here, but I have to square it. So that means I'm actually going to do negative y minus 1 quantity squared and then finish writing the second equation. plus y squared equals 25. Okay, now you have to figure out what this whole thing is. And trust me, it's not just square this and square this. You have to FOIL it. You're going to get a trinomial when you work this out. Okay, so to save you time, I already did the trinomial, and it works out to be y squared plus 2y plus 1. Then you have to tag on the rest of the problem, plus y squared equals 25. Okay, now combine like terms. There's a y squared, there's a y squared, giving you 2y squared plus 2y. But you're going to have to take that 25 and bring it over and combine it with the 1. So 25, when you bring it over, will make a negative 25. When combined with that 1, will make a negative 24. Okay, so again, what I did, 25, bring it over here. You crossed an equal sign, that makes it a negative. Positive 1 and negative 25 will make a negative 24. Okay, now we need to proceed to simplify and factor. All right, so you'll notice all of these guys share a value of 2. So I could factor a 2 out of all of these. Factor out a 2. Here's what you're left with. Y squared plus y minus 12. All right. Then I have to factor it. All right. So we factor this in to 2 binomials. Y, let's see, this is going to be plus 4 and y minus 3. Okay. Because positive 4 and negative 3 multiply and make a negative 12. Positive 4 minus 3 make a positive 1, which is what I need right there. Now we have to solve these. So this side makes a negative 4. This side makes a positive 3. That means y is equal to negative 4 and positive 3. We're not done, but we do know that we will have 2 solutions, because when we worked this whole problem out, we had 2 y values. We need to find the 2 x values that they match up with. So we just so happen to have an equation right here already set up for x. So I'm just going to move that down here so you can see it. So that's the x equals negative y minus 1. And we're going to have to plug in values. Negative 4, plug it in right there. What's that going to look like? That's going to look like x equals a negative and a negative. That's just going to be 4 minus 1. So x equals 3. Then you're going to have the other equation where x equals a negative 3 minus 1. So x will equal a negative 4. Now you have to put those points together because you have the x's and the y values. Now let's change our color to make a final answer here. So when x is negative 4, that's when we plugged in a positive 3. When x was a positive 3, that's when we plugged in a negative 4. So they weirdly enough work out to be almost like perfect opposites here. So that is our solution. 2 solutions at those 2 points. All right, last example problem already worked out. Let's save some time here. Solve with elimination. You will see that both of these guys are 25, meaning those are the terms we will be eliminating. Positive 25, meaning I have to use subtraction. If they're the same sign, use subtraction. All right, they will cross out. Then 9 minus negative 16, negative and negative will actually turn to a positive. So that's going to be 9 plus 16, which gives me 25y squared. But this is where things kind of take a turn. 225 minus 400 creates a negative. So if you don't see the writing on the wall yet, well, then keep following. Divide both sides by 25, and that's going to give you y squared equals a -7. That is not possible. You can never create, let's look at the note, never create a negative because a squared value can't equal a negative. So this is actually no solution. So through all these example problems, you saw a 1 solution, a 2 solution, and a no solution. You could in the homework get one with 3 solutions or even 4 solutions. All right, so let's zoom out. Look at all of our example problems right there, 1, 2, 3, and there you go. All right, that's the final section for chapter 10. All right, bring your questions to class. Don't forget, ask those questions, take some ownership of the grade there. I'll see you guys in the next one.